Okay, let's draw some cylinders. Now I know what we normally think is a cylinder. What I want to do is first show that what we normally think is a cylinder is a special case of what a cylinder is what we're going to see in Calc 3. Now according to the directions, a cylinder in Calc 3 is the graph of an equation that's missing a variable. So let's write down something that doesn't have three variables. How about something like x squared plus y squared equals 1. No z at all. Now, the directions say this. Draw what we would normally see. What we would normally see in the xy plane is just a circle. And then what we're supposed to do is draw lines that are parallel to the missing axis. Missing axis in this case is z. So I'll push it up. And then we're going to try to draw exactly the same thing again. Drawing the exactly same thing again. And we can see that the graph of x squared plus y squared equals 1 in 3 space is what we would normally call a cylinder. Now, really, when you took algebra or calculus, they always were very careful to call that a right circular cylinder. The right means it went straight up. The circular means the graph that we're actually making a cylinder out of is a circle. If I now want to add the axes, I certainly can. We just add the axes, and you can see a lot of times it's much easier to draw the thing first then add the axes later. So that's our first example where we see that the graph of a regular cylinder is actually an example of what we're calling a cylinder. Now let's look at a couple of different examples that we'll see many times this semester. I'm going to draw something like, how about z equals, how about y squared? Z equals y squared. Well, what I'm going to do, because I don't really know what that looks like, I am going to put my axes in first this time. Axes go like this. Z equals y squared. Well, if this is y, and that's usually how we would normally put this, and this is z, what we have here, right, is just a parabola. Now what I'm supposed to do is draw lines that are parallel to the missing axes. Well, the missing axis in this case is x. So what I'm going to try to do is draw x like that, and then something that's parallel like that, and then I'm supposed to try to draw the exact same thing again. Never easy if you're me, but how about we just try to do it like this, and like this. I don't like it. Hold on. Let's try going all the way down here like this, and then down up here like this. I think that's better. I'll go across like this. I'll go across like this. Now remember, the only thing we're actually looking at is not these lines here. They're just lines that are helping me see what's going. What I see is an infinite taco, and I will often refer to it that way. An infinite taco. I frequently just, I like being the parabola and just walking along the x-axis in an infinite way. But you can see that it is an infinite taco. It's an infinite empty taco, unfortunately. All right, so that's another example. Another one would be a curve that we would see a lot in algebra and calculus. How about something like z equals e to the minus x. E to the minus x, well, okay, hold on one second. E to the minus x normally looks like this. Now that's if this was the x-axis and this is the z-axis. What I'm going to do is see if I can't draw something that actually is going to be meaningful, remembering that this is the x-axis, this is the y-axis, this is the z-axis. E to the minus x, in this case, let's see, actually comes up like this and goes up like that. Now it keeps going, and I'm not going to worry too much about it. What I want to do is draw a line that's parallel to the missing axis, drawing a line that's parallel to the missing axis, try and draw the exact same thing again. And it kind of looks like a slide. What we can do are add some extra little lines that actually help us see it. For example, I'm going to draw what would happen if I had slid the axes over. So I'm just going to draw this like this, and this like this. And I'm going to claim that actually makes it you can see the slide much better this way. Now the slide itself, right, is just this curvy part in here, right? So the cylinder are not these lines, but I think you have to put those lines in to actually make it see it. I think that's right. Is there any other one that I think we can do without killing ourselves? One more. Before I set you loose on them. We've already done something like x squared plus y squared equals 1. How about something like x squared plus z squared equals 1? Well, I know that's a cylinder, except it's going in the direction of missing y. Now, I can try to put the axes in, but that's going to suck. I know what I'm going to see is a circle here. I'm going to draw lines that are parallel to the missing axes. I'm going to draw the circle again like this. And I see that it goes forever this way. And again, you see what I did here, yes, is I drew it first. And now I'll put in the axes. And it makes a lot more sense. Now it does go forever this way, it does go forever this way. But in general, you're going to see these a lot in physics, you're going to see these a lot in probability and statistics. And in cool problems in math as well, but that's it. So that's our first little tutorial on how to draw cylinders and the kind of cylinders you might see.